Greetings, everyone. I'm Lochana M, and I'm currently in my seventh semester at GSSS IETW, and I'm studying in Artificial Intelligence and Data Science branch. So today I'll be presenting my project, which is the chronic kidney disease prediction using ML, which I've prepared for the Samsung. So the main objective of this project is to make sure that the kidney disease are predicted in their early stage, because when the disease reaches their last stages, it is very difficult for the patient to recover. So the main real life aim of this project is to detect that disease in the early life. So, and the data set I have used is of the Kegel chronic kidney disease .csv, which is available in Kegel, and it has almost 400 data values, which has values such as age and their lifestyle values, such as whether they smoke or drink and all. And also they have some biological data such as hemoglobin content and also blood sugar content, BP pressure and all. So this is my code. So I have used Streamlit, which is a Python library which makes sure that without the use of HTML or CSS, the front end which is developed, and pandas for reading the CSV, and for NumPy for numerical calculations, and sklearn have used to train and split the data set into numerical and categorical data, so that my data calculation becomes easier. And I've used pre-processing for standard scalar for the numerical values and one hot encoder for the categorical values. And I've used pipeline so that the integration of the different parts of the code becomes easier. I've used matrices for the calculation of accuracy. The accuracy of the code which I've used is almost 91%. So the code accuracy is very good compared to other modules. And also I've used the model as XGBoost, which is very powerful, and it also works with the inconsistent data, but the structured data is preferred. And I've used SHAP, which plots the different attributes and shows which attribute contributes to the disease most. And also I've used Plotly and Seaborn to make sure that I have interactive plotting in the displayed in the app, which also helps the user to visualize and also make sure that user easily understands the visualized data than the which is predicted and which is more complicated. So first of all, I've loaded the data set and I've read it using the pandas module, and I've set the target column as diagnosis, which will be in the bits form, which is 0 and 1. So 1 represents the presence of CKD and 0 represents the absence of CKD. And then I've used the df.drop to drop inconsistent values, and which is patient ID and doctor in charge, which are not necessary. And then have trained splitted the data set into xtrain and ytrain, xtest and ytest, and then I've pre-processed the data, and then I've built the pipeline to make sure that the code are integrated properly. And I've trained the model using pipeline.fit, and I've fed the y prediction. And then I have used the Streamlit, which Streamlit module, which ensures the front end of the app. The title of the app will be Chronic Kidney Disease Prediction. And then I've used model evaluation to that, which displays the accuracy scores and also the confusion matrix, which contains true positive, true negative, false positive, and false negative values, so that the user can evaluate the model efficiently. And I've just saved the model, which ensures once I run the code, the model will be saved as CKD streamlit.pkl, which ensures the model does not need to be trained again and again. So that saves our time, and it increases the efficiency of the model. And then I've displayed the summary of the data set, and then I've made sure there are interactive bar chart, which is as follows. So this is the F1 score and the confusion matrix, which displays the true positive, true negative, and false positive and false negative. This is the data set summary, and this is the average CKD, chronic kidney disease versus non-CKD, which also shows how many kidney disease sufferers are there and how many are not there. I have took on the search suggestion, and I have made sure each values are displayed. When I select age, the average of age and CKD, presence of CKD and non-CKD according with respect to their ages are displayed. And then I have we can select other features like gender or ethnicity. The column names which are in the CSV can be also visualized using this, which ensures that the drop up displays each and every column names. And then there are visualizations. These are interactive visualizations. So when I place my cursor on wherever I need, the data is displayed like diagnosis is equal to 1, age, the age and the count, how many count are there. And then this is the violin plot. This is also an interactive plot which I've used. And this also can be set to various column names and also visualized respectively. And yeah, we can use BMI and all. This is the correlation heat map of the total data set which I've used. And this, yeah, this I have told, as I've told, this is very important to analyze the contribution of various attributes to the disease causing. And also, this is in this we can in real time we can know whether we have the kidney disease or not. Like if we have the report and we have these values, we can just change the values, and we can check whether we have the disease or not. Yeah, this shows that the streamlet is running, and at the end we get the result. If it gives 1 if you have the chronic kidney disease, or else it will be 0. For 0 we can change, 1 second. Yeah, this to almost 0.1. I guess this will work. uh, the various values also depends upon the prediction. So this is my project, and thank you sir for the opportunity given to me.